What's up, everybody? I was doing some lab analysis with the new Vernier graphical analysis software, and I thought it was such a slick tool that I wanted to make a video tutorial about how to use it. Using our data from up above, I'm going to show you how you can create a graph using the manual entry function of the Vernier Graphical Analysis 4 app. So here we are. We've got our lab data. This is the same lab data that I posted to Schoology, and I did my delta t's. And what I want to do now is open up the Vernier app and choose the bottom option that says manual entry. And it'll basically open up a blank graph and a blank table for you to put data into it. Now immediately, these two headings over in the upper right hand corner where you put your data sets in are going to be just labeled X and Y. And if you click on the three dots, you can rename them and identify them as delta T, and also allows you to put in the unit for degrees Celsius, and also for the X, CLO minus, and I put in the unit of milliliters. So I start putting in my data. I put in the 5, 10, and 12.5 milliliter data points for the CLO minus, and then I put the corresponding changes in temperature along with them. If you read the lab write-up down there in the calculation section, I ask you to graph basically two sets of data. One set of data for trial 1 and trial 2, where the CLO minus is the limiting reactant, and also trial 3, where they actually run out or are designed to run out at the exact same time. And so I put those three data points in what I refer to as data set 1. Then what happens next is I hit the three dots here next to the data set, and I choose add additional data set. And what that does is open up a new data set graph, which I can put in some more data for. So as the lab write-up mentions, I want to put in the lab data where the SO3 is the limiting reactant, and I also want to include that trial 3 where they ran out at the same time. So now I choose these last three data points, trial 3, 4, and 5, and write in those changes in temperature likewise. Now I have two data sets. If you look over at the graph on the left-hand side of the page, you might not see all the data points because only one of the data sets might be viewed at one time, but what you do is you click on the delta T degrees Celsius over here, and what happens is a field of text opens up and you're allowed to turn on and off multiple data sets at a time. So what you want to do is turn on both data sets so you can view them both at the same time. So now it's time to come up with some lines of best fit for my two different data sets. And I want to use this tool or function down here, which is the little graph tool. So go ahead and hit that, and up pops another text box. Now once that opens up, there's lots of different options to choose from. We used the view statistics option during our particular lab to talk about the maximum and minimum of the data set that you were collecting when it came to temperatures. But in this case, we want to take a look at three data points and highlight them and apply a curve of best fit that you see right here. So what you do is you actually might want to get this out of here so you can close it. So just click on the graph and it'll probably disappear. And then what you do is you click, hold, and drag over and highlight the first three data points in red. And then you hit apply curve fit and it defaults to linear, and you hit linear and you get a line that runs through those three data points and also a little box of information. Now don't delete that box of information because you're going to need it in order to do the last part. Now once you generated a line of best fit for those first three data points, I want you to do the same thing for the last three data points. All you need to do is click, hold, and drag over so that these three data points are highlighted, and once again hit this icon on the bottom left and choose apply curve fit, hit linear, and it'll pop out another line for the blue set or set 2. And here's what your graph will probably look like, or something similar to it, if you had different data points anyway. So I've got a red set of data with a red line. This line of best fit applies to the first three data points, and the blue line of best fit applies to the line of the last three data points, with that one in the middle is actually counting for both the first and second data point. The important part of this graph, or the part that I want to focus on, is the part where the two lines intersect up here above this third data point from trial number 3. Using our experimental data, we were able to determine the maximum delta T that these reactions would result in if all 5 experiments were performed error-free and identically. The two lines would intersect directly over this point in which both of the reactants run out at exactly the same time, the perfect mix stoichiometrically. But due to the introduction of some error, that intersection is a little bit high and a little bit to the right of that point. but that is what our data says is the ideal maximum change in temperature, and so we're going to use that to do the remainder of our calculations. Now in the past, I asked my students to take a pencil and a straight edge and drop a vertical line and determine and estimate whereabouts on the horizontal axis this one line fell, and estimate using your best estimation powers. But now that we have this information over here, we can actually do this much more precisely using our good old friend y equals mx plus b, because we have a y equals mx plus b data, the m being the slope and the b being the y-intercept of the red line, and we have a slope and intercept of the blue line. Now if you remember from algebra, if you take two lines and set them equal to each other, where substituting in y of one for y of another, you have mx plus b is equal to mx plus b. And if you solve for x, you will be able to determine the perfect or the exact volume along the horizontal axis at which these two lines would intersect, taking into account the maximum delta t on the vertical axis. So instead of estimating along the horizontal axis where this line falls, we're going to measure using math the exact x, the exact volume that will result in the highest delta t value. The remainder of the calculations can be done using stoichiometry and a calculator and q equals mc delta t. But for generating a graph, I find that this app is much more useful than Excel or even Google Slides or Google Sheets in order to create the graph that gives you the desired outcome. And honestly, it didn't take me too long to figure out. So I hope this little video tutorial was helpful. Thanks for watching.